Every day, about 200,000 tons of aluminum are produced. The United States alone consumes more than 4.6 billion kilograms per year. To meet this huge demand, millions of tons of ore need to be processed. But how do you turn a reddish rock into one of the most prized metals on the planet? In this video, you'll see where aluminum comes from and how it's made. Civilization couldn't survive without it. This marvel of engineering is everywhere. It's an integral part of airplanes, automobiles, and the high-voltage cables that bring electricity to our homes. Unlike iron, which rusts and deteriorates over time, aluminum forms a layer of aluminum oxide on its surface that protects it from corrosion. It's 3 times lighter than steel. Thanks to its low density and high strength, it has become the main material used in aircraft manufacturing. But it was only in 1807 that the British chemist Humphrey Davy first identified the metal in a salt called alumina. Identifying it was the easy part, but isolating it proved to be a great challenge. It took about 20 years before the Danish chemist Hans Christian Ørsted managed to extract the metal. Even so, the process was so complicated and costly that until the beginning of the 20th century, aluminum was worth more than gold. Napoleon III even used aluminum cutlery for his most important guests, while the others had to make do with gold cutlery. Everything changed in 1886 when a discovery made aluminum accessible and affordable. 2 scientists working independently, the Frenchman Paul Ahu and the American Charles Martin Hall, developed an electrochemical extraction process that is still used today. They discovered that by dissolving aluminum oxide in a salt called cryolite and applying electricity, the oxygen atoms separate, leaving behind metallic aluminum. This method made it possible to mass-produce aluminum at a much lower cost, revolutionizing the industry. But where does aluminum come from? It is found right beneath our feet, attracting miners because it is the most abundant metal in the Earth's crust, making up more than 8% of its composition. However, in nature, aluminum does not exist as a pure element. Unlike gold and silver, there are no nuggets or veins. It can only be found in the reddish deposits of bauxite. The most abundant deposits are located in Australia, Guinea, Brazil, and Jamaica. The Hanley mine, owned by Alcoa, is located in the middle of the Australian mountain range. These mountains are mostly made up of bauxite
são formadas em sua maioria por bauxita
and make up the largest mine of this ore in the world, from which approximately 23 million tons are extracted per year. However, most of the bauxite cannot be removed without first drilling through an underground rock barrier more than 5 meters deep. For this, they use enough explosives to demolish a 10-story building. First, the rock is drilled. Then, the explosive is inserted, which is based on ammonium nitrate combined with fuel. Each month, they use between 700 and 900 tons of ammonium nitrate. Every day, thousands of tons of ore containing aluminum oxide are detonated. With each explosion, about 2 hectares of land are opened up, and between 50,000 and 100,000 tons of ore are released. Each ton of ore may contain only a few kilograms of aluminum, so a large amount of bauxite must be processed to produce a single ingot. To obtain 1 ton of aluminum, approximately 4 tons of bauxite are required. Billions of dollars in investments are needed for extraction. Nowadays, aluminum is priced at $2.65 per kilo, and the mining industry invests in large-scale equipment. This excavator is the largest in the world and costs more than $20 million, also making it one of the most expensive. The off-road trucks can carry up to 270 tons of bauxite, and the excavator loads 1 ton in 3 movements. The truck arrives empty and leaves fully loaded in just 1 minute. Then the trucks unload the ore at the processing plant. To extract aluminum from the ore, a refining process called the Bayer process is carried out. The conveyor belt deposits the ore into a gigantic rotating drum, where huge steel balls grind it until it turns into a fine powder. The bauxite powder is then mixed with caustic solution, which separates the aluminum oxide from the rest, resulting in a concentrated solution of aluminum oxide. And then comes the most surprising part. This solution is dried into sandy crystals called alumina, the substance from which aluminum is made. The next step is to separate the aluminum from the oxygen. For that, the alumina is transported to an Alcoa production plant. A loaded ship leaves the port every 3 days. The alumina it brings will be transformed by the smelter into 30 to 35,000 tons of pure aluminum. Every 3 days, a ship arrives with about 100 tons of alumina. Next, all of its contents are sucked out by a kind of industrial super vacuum, which extracts about 300 tons per hour, emptying the ship in about 5 hours. The material is then placed on conveyor belts and taken to the factory, where the alumina is introduced into large electrolytic tanks filled with molten cryolite. The cryolite lowers the melting point of alumina from about 2050 degrees Celsius to about 950 degrees Celsius. To obtain pure aluminum, it is necessary to separate the oxygen atoms, which keep it strongly bonded, a process that requires a huge amount of electricity. That's why aluminum is known as electricity in solid form. Approximately a third of the cost of a kilogram of aluminum corresponds to electricity consumption. The energy used in the plant to power the cells could supply 300,000 homes. In total, more than 340 megawatts of electricity are consumed per year to produce aluminum. In the electrolytic cells, low voltage, high-intensity electric current is applied through carbon anodes and a cathode, initiating electrolysis. Electricity flows through the copper bars connected to the cells. The aluminum oxide molecules contained in them are made up of 2 aluminum atoms and 3 oxygen atoms. The electric current breaks these bonds, separating the atoms. The oxygen rises to the top of the container and reacts with the carbon anodes, forming carbon dioxide, while the denser aluminum sinks to the bottom of the tank. After electrolysis, the molten aluminum at about 950 degrees Celsius is separated from the cryolite by vacuum pumping. This procedure occurs in a continuous cycle every 36 hours to extract the metal from the tanks. Once extracted, the liquid aluminum is transferred to a transport crucible, a thermally insulated container designed to maintain the metal's temperature and prevent its premature solidification. In the refining furnaces, the aluminum is reheated to eliminate remaining impurities through processes such as filtration, which remove unwanted elements like hydrogen and oxides. Next, the pure aluminum is poured into molds to form ingots and subjected to a controlled cooling process, ensuring that it solidifies without structural defects. When the ingots are ready, they are sent to various industries, where they will become products for the automotive, aeronautical, and construction sectors. And that was today's video. Remember to like and subscribe to the channel.